Hi friends, welcome back. Today we are going to solve one of the important binary tree related problem on Leetcode. It's 1339 maximum product of splitted binary tree. So before we go through the description and through the examples, I just want to mention that my channel focuses on helping people who are preparing for coding interviews and Java interviews. On my channel, I have over 200 solved examples explained with Java code, and those examples were taken from previously asked questions from big tech companies like Amazon, Apple, Facebook, Google, Microsoft, Yahoo, and many other companies. And those consist of different variety of problems that includes dynamic programming, graphs, binary search trees, BFS, DFS, linked list related problems, string related interview questions, and many logical interview questions that were asked by many big tech companies. So if you are preparing for Java interviews or coding interviews, please subscribe to this channel. This channel can definitely help you in your job interview preparation. So please subscribe. So let's go through the description of this problem. Given root of a binary tree, split the binary tree into two subtrees by removing one edge such that the product of the sums of the subtrees is maximized. Return the maximum product of the sums of the two subtrees. Since answer may be very large, return modulo 10 raised to 9 plus 7, right? Note that you need to maximize the answer before taking the mod and not after taking it. So they have given us one example over here. So as you can see, the maximum product, if we cut this tree into two subtrees as shown here, right, where this left subtree has a sum 11 and right subtree has a sum 10, then if we take the product of 11 and 10, that is 110. So that is the maximum product we can get if we kind of cut this tree with this red branch, right, or red line basically, right? So let's go and we can discuss this over here and how we are going to solve this problem. So so first let me just explain you first like what the problem is. So as they already mentioned that we have to maximize the product, right? So for example, if you calculate the total total sum of this tree, right? So it is 6 plus 3 is 9 plus 1 10 12, and 12 plus 5 is 17 plus 4, which is equal to 21, right? So 21 is total sum. So for example, if we cut this tree over here, right, then you can see that 6 is the sum of this tree and remaining 15 is the sum of the other tree, right? So product will be equal to 15 into 6, which is equal to 90, right? So we know that it is lesser than this product of 110, right? So we have to maximize it. So this is the problem basically, right? So how we are going to solve this problem is we are actually going to try cutting the tree on all the edges, right? All the possible edges we will try to cut the tree, and then we will try to check the product, right? And wherever we find the maximum product, we are going to take that as the answer, right? So first thing what we wanted to do in to implement this solution is we want to calculate the total sum of this tree, right? That we already calculated for this tree, which is 21. And then after we calculate that, we will use our recursive a solution where we will start cutting the tree recursively from this end, right? So first we will cut tree here. So now if we cut tree here, then the product will be 4 into 17, right, which is equal to 68. So here I put it for the convenience that you can see how the trace of the recursive call goes, So first thing is here, if we choose this 4, right, the current sum will be 4 for this node and the product will be 68, as you can see, right? So we will just update our maximum product to 68, right? We will keep one maximum product variable, and then we will keep updating it whenever we find better product, right, which is more product. So here right now we are cutting at 4, we found 68. Then how the recursive call goes, right? It will go like this, and then it will take this as a another tree, right? So 5 will be another tree. So if you take 5, then 5 into 16 is equal to 80, right? So as you can see here, 5 into 60 is equal to 80. So we will update our maximum product from 68 to 80 here, right? Because 80 is bigger than 68. So after this, the recursive call will go like this, right? So now we have seen 5, so call goes from here to here, right? So now total, this total subtree will be 11, right? So 11 into remaining 10 is equal to 110, right? So as you can see here, 11 into the remaining means 21 minus 10, 21 minus 11, right? Basically, so it is 10, right? So that's what I meant by remaining. So here the calculation of 11 into 10 is 110. So we will again update our product from 80 to 110, because 110 is more than 80, right? So we wanted to keep track of what maximum we have found. Now after 2 is done, we will cut the tree from this branch, basically, right? From this branch. So now we will have this whole tree on the left side and 3 and 6 on the right side. So what it means is the product will be 11 plus 1 is equal to 12, right? So 12 is the sum of this subtree, sorry, sum of this subtree. So remaining tree is 9. So 12 into 9 is 108, right? So so here, right? So 6 we have chosen. So now actually before we take this one, right, it since it is a recursive call, it will go from this one to all the way until this point, right? Because it is a recursive call, it will not go to root first, it will go to 6, as you can see here. Then we calculated again product, but max product remain 110, right? Because if we take 6, then 21 minus 6 is equal to 15, right? So 15 and 15, so 15 into 6, right? So 15 into 6 is 90, but 90 is lesser than 110. So our 110 will be still the maximum product here. Now if we after that we will reach this tree, right? So now 3 plus 6 is equal to 9. So 21 minus 9 is equal to 12, right? So 12 into 9 is equal to 108. So 108 is also lesser than 110. So our product will be still, maximum product will be still 110, right? Because 108 is smaller than 110. So still our maximum is 110. And lastly, we will consider taking this. So we already now we will consider this point, right? And then we will take this subtree. So let me just highlight that tree for you. So this tree now is our left tree, right? So this whole tree now we are cutting basically on the left side, and on the right side this is the tree. So 6 plus 9, I think we already cut that. So this is 9, right? This is 9 sum, and this one is 12, right? 12 plus 9 is equal to, and 12 into 9 now. So 12 into 9 is equal to 108, right? So 108 is lesser than 110. So our product will be 110. So 110 will be the answer, right? That is the maximum product we can find when we cut these two subtrees, right? 11 and 10. So as you can see, that is what they are also finding here. So this is the way we are going to implement and solve this problem. So we will be recursively cutting the tree in all the possible branches, right? And then we will try calculating the product, and whenever we see maximum like product, then we will keep updating our max variable, right? So let us look into the code quickly. So as you can see, I first created a max product variable, and I just assigned it the integer mean value to that product. And first we will calculate the total sum of the tree, right? For example, in this case, total sum of this tree is 21 here. So that is what we are calculating by using get complete tree sum. So here I implemented a function. So it is just kind of a recursive function, right? So in case of root is null, we will return 0. Otherwise we will add root value plus the get tree sum of left side and get tree sum of right side of the node, right? So this is a recursive function, and this is our base case for the recursive function, right? Base case. And it gives us a long, so it will give us this 21 sum. So after we get that 21 sum here, then we will recursively call calculate subtree sum, right? Where we will pass a root here and we will pass total sum, right? And this is again our base case for the recursive function, right? Base case. Whenever root is null, then in that case we will just return 0, right? Otherwise we will just call this recursive function by passing the left side of the root and total sum, and by passing right side of the root and total sum. So we get left sum and right sum. Once we get left sum and right sum, then we will add the root dot value, right? For example, so let me just revert this color so I can reuse this space again and show you again, right? So let me just revert these colors. Yeah, so what it means is when we are at node 2, right, then left sum is 4 and right sum is 5. So total sum is 4 plus 5 plus 2, right? So that is what we are doing here, right? Left plus right sum plus root dot value. And after that we will calculate the product of this tree that we cut from original tree, right? For example, if we cut this from original tree, this tree, then we will calculate this sum basically, right? So sum is equal to 11 here, right? 11 here, and then the remaining sum of the other tree will be 10, right? Because we know the total sum is 21. So that is what we are doing here, right? So current product, we are calculating total sum, which is 21 for our in our example. Current subtree sum is 11. So 21 minus 11 is 10 into current subtree sum, right? Current subtree sum is 11, so which is equal to 110, right? In that example. So that is what we will calculate. And whenever we found this current product is bigger than our max product, we are going to use math.max to update the max product value, right? And at the end we will return the current subtree sum, right? This current subtree sum we will return, right? And this is how the calculate subtree sum function is recursively implemented. And at the end we found, because it's a recursive function, it will keep going, like keep cutting the tree in all possible branches and keep calculating the max product for every cut, right, that we are doing, actually every tree cut that we are doing. And at the end we are just going to return the max product mod this big value that they have given us, right? 10 raised to 9 plus 7, and we'll just convert it to int. I just used a long here because they said that this can be a big value, right? So this is the way we are going to implement maximum product of splitted binary tree, right? So let us take this example, that is the same example that they gave us, right? So this one, so 110 we should get as our answer. So we are getting 110, so which is correct. So let us take all the examples that they gave us and make sure that it is working for all these unit tests, right? So let's submit this. So for second we are expecting 90, and so we are getting 90. For third 10, 25, and for fourth 1. So all are working fine. So we can just go ahead and submit our solution. So our code is accepted by Leetcode solution, and it is 95% faster than other submissions and 85% faster on memory side, which is very good. And this is the way we can implement maximum product of splitted binary tree by using recursive function. So we calculated the total sum of this whole tree, and then we simulated cutting this tree out on every branch, right? Like here, then 5, then this whole, like 2 4 5, then 1 2 4 5, every possibility we have tried actually, and then to decide, the maximum product which is possible. If you haven't already checked my playlist on my channel for Leetcode and Leetcode solutions, please check it now. It has over 200 solved examples explained with Java code and details, and those problems were taken from big tech company coding interviews that includes like Amazon, Apple, Facebook, Microsoft, Google, Yahoo, etc. And those were handpicked problems that consist of variety such as dynamic programming, graph related problems, binary search trees, binary search related problems, linked list, string related interview questions and coding problems, as well as logical coding problems. If you are preparing for Java telephonic interview, then there is another playlist called as Java interview that explains, frequently asked interview questions for Java and how to answer those questions, and Java concepts, as well as architectural and design pattern related questions. So please go through that. Um, if you like this video and if you find this solution helpful, please hit like and subscribe to the channel. Your subscription is really important to us because that is the way the video can reach to more people. They can also watch these videos while they are preparing for their coding and Java interviews and get helped. And so please subscribe to the channel, and thanks for watching this video.